In this video, we're going to be talking a little bit in more depth about variables in Matlab. If you haven't watched the Introduction to Matlab video first, or if you've had any issues getting Matlab installed, I recommend pausing this video and either watching the first one in this unit or reaching out to me or your TA for help in getting started with Matlab. Otherwise, welcome to this video. Something a little bit different I'm trying is having this copy of my keyboard displayed so you can see exactly what keystrokes are being made. You can let me know in the comments below if this is helpful or if it ends up being too distracting. But otherwise, let's get into the video. So first thing we're going to talk about is we're going to review the asymmetry in variable assignment. So remember, if I want to set a variable, the name goes on the left. So I'm going to call it, let's say, my var, and I'm going to set it equal to 2. And remember, here in the workspace, it's showing us all of the variables I currently have defined, and my var is equal to 2. Now, what if I try something like this? What if I say 3 equal to a? So take a minute and think about what you think is going to happen. Here we can see this error message highlights the asymmetry that we were just talking about. So it says incorrect use of equal operator. Assign a value to a variable using equal and compare values for equality using double equal. So don't worry about this double equals yet. But equals, basically what this is saying is that 3 is somewhat of a protected value, right? Like 3 is a number, we don't want it to be anything else. So we can't put 3 on the left, but if I try something like a equal 3, so I switch the order, this is going to give no error, and we see that a gets at the 3. One thing I do want to say here is it's generally good coding practice to give your variables descriptive names. So for instance, let's say I'm measuring the price of something. It might make sense to call your variable price or price underscore whatever the item is. In general, using variable names that are just a single letter like A, B, C, that's not the best practice, but because in this video we're not trying to solve any particular problem, we're not working on a project or anything like that, we can kind of get away with using these not descriptive variable names. Just something to keep in mind. All right, so we're not limited to just these. I could say, what if I wanted B to be something like, let's say, pi minus 10? I could say C is equal to 3 times, let's say, 15. And let's make one more. Maybe let's say D is equal to, I don't know, let's try like 7 times 9. So we can see here in the workspace, lots of variables have been defined. And if you remember from the previous video, we talked about how to clear all of the variables at once. But maybe I realized, I don't really need this C variable. What I can do is say clear. So remember, that's the same word as before. But now I'm just going to write C after and hit return. And if it works, we're going to see it disappear from the workspace. So now we see A, B, D, and my var, but C is gone. So that's how we can clear a single variable. If I want to clear all of them, remember I just type the word clear, nothing after it, and press enter. And now we can see that all of our variables have disappeared from the workspace. We're kind of working with a clean slate. So let's get some of our variables back. Maybe I missed them. Let's say I want B, and maybe my var, maybe one more. Let's get C back. All right. Another command that I'm going to show you in this video is who. Just like this, if I press return, it's saying your variables are B, C, and my var. So same information that we have here in the workspace, just displayed now in the command window. If I add one letter after who, so if I write who as whose and press return, this gives me a little bit more information. So it tells me the name of the variable, its size, its bytes, class, and any attributes. So don't worry about bytes and class just yet. That's something that we'll talk about more a little bit later. But for now, let's take a look at size. So Matlab is very, very good at dealing with matrices. And I believe the original meaning of Matlab was matrix laboratory. So what Matlab is saying the size is 1 by 1 is they're saying, okay, think of these variables, B, C, and my var. Remember, these are just numbers. Think of these as 1 by 1 matrices, so just a single value. And let's see, I think that's all I want to say about who and whose. But I did mention matrices are very useful and important in Matlab, so let's talk a little bit now about how we actually define matrices. So before I kind of show you the two-dimensional ones that we might see in a linear algebra course, let's start with kind of the smaller versions or the special cases, so row vectors and column vectors. So remember, you can think of a row vector as something like, so let's say v equals, I'm going to use square brackets, and I'm just going to put whatever numbers I like. So maybe 1, 2, 3, and 7. So we can see here it's one row and 1, 2, 3, 4 columns. So this is what's called a row vector. And this is how matrices, or they're also called arrays, are defined in Matlab. So we have these square braces. If I press return, we have v equals, and we can see it here. If we look in the workspace, it displays it with the square brackets. So something we can do is we can say, well, what's the length of v? And that returns 4. And what that's saying is there's 1, 2, 3, 4 elements in this row vector. Another thing that we can do is we can say size of v. And the answer here, it gives us, you can think of this as 1, 4. So this 1 is telling us the number of rows. This 4 is telling us the number of columns. So typically in coding, when you want the size of an array, a 2x2 array, or not 2x2, like a two-dimensional array, it's going to be rows, columns. And the way that this was taught to me when I was first learning to code was that you can remember it by thinking of remote control. So RC standing for rows, columns. So that's just how I remember it. So again, here this 1 is saying V has 1 row and 4 columns. We can also define these row vectors without using these commas. So for instance, I can say W equals, I don't know, let's say 1, 2, 3. And we can see here in the workspace, it displays exactly the same as when we defined V. We can do all of the same operations on it. I can say, well, what's the length of W? We get 3. What's the size? This would be a good time to pause and check your understanding. What do you think the size is going to be? We get a 1/3. One other thing we might try is, well, what if I wanted to add V and W? So let's remember what both of them are. Remember, W is this 1, 2, 3. V is this 1, 2, 3, 7. What do you think is going to happen if I try V plus W? And if you guessed that the dimensions wouldn't match up, you would be correct. So what this error message is saying is arrays have incompatible sizes for this operation. So what it's saying is, well, W has these 3 elements, V has 4, so how could I combine them? Maybe if I had, let's say, another row vector called Z, and let's say it's 4, 5, 6. What do you think will happen if I try Z plus W? So we can see here, that one worked without a problem. And remember, W was 1, 2, 3. So here I do 4 plus 1 is 5, 5 plus 2 is 7, and 6 plus 3 is 9. So because Z and W, they had compatible sizes, we could add them together. So I've showed you how to make a row vector. What about kind of a two-dimensional matrix that you might see in a linear algebra course? The way that's done in Matlab is I'm going to call it by a capital variable. You don't have to, but the convention is, if you're doing a two-dimensional array, that you want it to be named with a capital letter. So let's call it A. I'm going to say equals, and we're going to start out exactly the same. So maybe I want it to be, I don't know, let's say 1, 2, 3. So that's going to be the first row. When I want to start the second row, I type semicolon. Then I do 4, 5, 6. Let's say that's going to be the second row. And let's go for a 3x3 maybe. So let's do 7, 8, 9. I'm going to press enter. And there is my matrix, my array, A. So a couple of things that we can do is we can check the size of A. Again, good place to pause and double check that what you think it'll be matches. So here we get, it's a 3x3. 3 rows by 3 columns. I think the last thing I want to show you today is notation that's very common in coding, but if you saw it in one of your math classes, it might seem very strange. And what this is let's say, let's go back to the variable C. So remember, C is 45. What if I do something like c equals c plus 1? And here's where you're going to remember the asymmetry. So what we're saying is let's call the variable c. We're going to assign it to the value c plus 1. So at this moment, c is the value 45. So 45 plus 1 is going to be 46. So when I press return, c is updated to 46. And again, we can see C46 updated here in the workspace. One thing that you might not expect, so let's remember what our row vector v was. It's this 1, 2, 3, 7. We could try something like v plus 1. And what that does is it adds 1 to every element of our row vector v. So we got 1 plus 1 is 2, 2 plus 1 is 3, and so on. Similarly, let's remember we have our 3 by 3 matrix A. I could say something like A equals, let's say, I don't know, 10 times A. And we can see now that every entry in A has been multiplied by 10. So I think this is a good place to stop for this video. Maybe one thing that I can leave you with if you want to try to test your understanding is I showed you how to make a row vector. I showed you how to make a matrix that's two-dimensional, so it has more than one row, more than one column. How do you think you could make a column vector? So try it out, and of course ask me or your TA if you have any questions, and I will see you in the next video.